The Accidents That Changed the World. Slow version. London, 1928. A group of motorsports sort of raced through a lab. They drift onto the pier 3 days, and when they land, they germinate a medical revolution. This lab belonged to Alexander Fleming, a Scottish scientist investigating the property of infectious bacteria. At this time, Fleming is away on vacation. When returned, he found a colony of mold growing up petri dish he forgot to place in his incubator. And around this colony of mold is a zone completely and unexpectedly clear of bacteria. In studying this mysterious phenomenon, Fleming came to realize that the mold was secreting some kind of compounds that was killing the bacteria. The mold was a species in the penicillin genus, so Fleming dubbed this antibacterial compound penicillin. What Fleming stumbled upon was a microbial defense system. The penicillin mold constantly produced penicillin in order to defend itself from threats, such as nearby bacterial colonies that might consume its resources. Penicillin destroys many types of bacteria by disrupting synthesis of their cell walls. These walls get their strength from a thick protective meshes of sugar and amino acids. They are constantly being broken down and rebuilt. Penicillin binds to one of the compounds that weaves these meshes together and prevents the wall from being reconstructed at a critical phase. Meanwhile, penicillin stimulates the release of highly reactive molecules that cause additional damage. Eventually, the cell structure breaks down completely. This two-pronged attack is lethal to a wide range of bacteria, whether in petri dishes, our bodies, or elsewhere. It's not, however, harmful to our own cells because those don't have cell walls. For a decade or so after Fleming's discovery, penicillin remained a laboratory curiosity. But during World War II, researchers figured out how to isolate the active compounds and grow them all in large quantities. They then wanted to win the Nobel Prize for their work. Teams at Oxford and several American drug companies continued development, and within a few years, it was commercially available. Penicillin and similar compounds quickly transferred the treatments of infections. For the time being, they remain some of the most important life-saving antibiotics used in medicine. However, the more we use any antibiotic, the more bacteria evolved resistance to it. In the case of penicillin, some bacteria produce compounds that can break down the key structure that interferes with cell wall synthesis. As antibiotic use has increased, more and more bacteria have involved this defense, making these antibiotics ineffective against a growing number of bacterial infections. This means it's essential that doctors not overprescribe the drug. Meanwhile, 5 to 15% of patients in developed countries self-identify as allergic to penicillin, making it most commonly reported drug allergies. However, the vast majority, over 90% of people who think they are allergic to penicillin actually are not. Why the misperception? Many patients acquire the allergy label as children, when a rash appears after they treated for an infection with penicillin or closely related to drugs. The rash is often blamed on penicillin, while the more likely culprit is original infections. or a reaction between the infection and the antibiotic. However, genuinely penicillin allergies, where our immune systems missed penicillin for an attacker, do occur rarely and can be very dangerous. So if you think you're allergic but don't know for sure, your best bet is to visit an allergist. The complete evaluation that will confirm whether or not you have the allergy. Even if you do have penicillin allergy, your immune cells that react to the drug may lose their ability to recognize it. In fact, about 80% of people who are allergic to penicillin outgrow the allergy within 10 years. This is great news for people who currently identify as allergic to penicillin. The drug may one day save their lives, as if done for so many others. One more with normal speed. London, 1928. A group of motorsports surfers raced through a lab. They drove on the petri dish and they went land Germany's medical revolution. This lab belonged to Alexander Fleming, a Scottish scientist investigating the property of infection bacteria. At the time, Fleming is away on vacation. When he returned, he found a colony of mold growing up petri dish he forgot to place in his incubator. And around this colony of mold is a zone completely and unexpectedly clear of bacteria. In studying this mysterious phenomenon, Fleming came to realize the mold was screening some kind of compounds that was killing the bacteria. The mold was a species in the penicillin genus, so Fleming dubbed the antibacterial compounds penicillin. One Fleming stumbled upon was a microbial defense system. The penicillin mold constantly produced penicillin in order to defend itself from threats, such as nearby bacterial colonies that might consume its resources. Penicillin destroyed many types of bacteria by disrupting synthesis of their cell walls. This wall gets the strength from a thick protective mesh of sugar and amino acid that are constantly being broken down and rebuilt. Penicillin binds one of the compounds that weave these meshes together and prevents the wall from being reconstructed at a critical phase. Meanwhile, penicillin stimulates the release of high reactive molecules that cause additional damage. Eventually, the cell structure breaks down completely. This two-pronged attack is linked to a wide range of bacteria, whether in petri dishes or bodies or elsewhere. It's not, however, harmful to our own cells because those don't have a cell walls. For decades or so after Fleming's discovery, penicillin remained a laboratory curiosity. But during World War II, researchers figured out how to isolate the active compounds and growing them all in the large quantities. They then went on to win the Nobel Prize for their work. Teams Oxford and several American drug companies continued development, and within a few years it's commercially available. Penicillin and similar compounds quickly transformed the treatment of infections. For the time being, they will remain some of the most important life-saving antibiotics used in medicine. However, the more we use any antibiotic, the more bacteria involved resistant to it. In the case of penicillin, some bacteria produce compounds that can break down the key structure and interfere with the cell wall synthesis. As antibiotic use has increased, more and more bacteria have involved this defense, making the antibiotics ineffective, making growing a number of bacterial infections. This means it's essential the doctor not overprescribe the drug. Meanwhile, 5 to 15% of patients in developed countries self-identify as allergic to penicillin, making it the most commonly reported drug allergy. However, the vast majority of 90% of people who think they're allergic to penicillin actually not. While the misconception, many patients acquire allergy label as children when the last period after the treatment for infection with penicillin or closely related drugs. The rash is often blamed the penicillin, while the more likely culprit is original infection. or reaction between the infection and antibiotic. However, genius penicillin allergies, where our immune system mistakes penicillin for an attacker, do occur rarely and can be very dangerous. So as you think of allergy to but not sure, your best bet is to visit an allergist. The complex evaluation that confirm whether or not you have an allergy. Even if you do have a penicillin allergy, your immune cell that reacts to the drug may lose their ability to recognize it. In fact, about 80% of people who are allergic to penicillin outgrow the allergy within 10 years. This is great news for people who are currently identifying as allergic to penicillin. The drug may one day save their lives, as it's done for us so many others.